All right, guys, we're on Unit 5, Day 10, and we're going to talk about some more formulas. All right, these are compounding interest, and we're also going to talk about half-life formulas. So again, because they're formulas, they're easy to use. You just have to make sure that you're using the correct formula and plugging in the correct numbers for the correct variables. And so this is a compound interest formula. All right, and this is for using it when the problem is talking about n times a year. Okay, so you're going to use it when interest is compounded or applied at different time periods per year. Okay. And if we look at this formula, guys, instead of y equals, they use what they call a of t equals. All right. However, guys, it's still your y value, right? Just kind of like f of x is the same thing as y. A of t, guys, is the same thing as y also, and it still represents our final amount like it did in our formula from day 9. Okay, so that's that. Your p is your initial amount. When we use the other formula, y equals ab to the x, this used to be an a, all right? But in this formula, they call it a p, and that's your initial amount, okay? Your r still represents your rate, and remember that you have to move the decimal place over if it's a percentage to turn it into a decimal. Okay, or you could divide by 100. Right here, guys, before we get to that r in the formula, they have 1 plus because this is an interest formula. Interest always goes up, and so they built the 1 plus into the formula, unlike the other formula we were using the other day that's used for growth and decay. When you compound interest, it always goes up, and so that 1 plus is permanently there in the formula. Okay, there's your r value. N is going to represent the number of compounds per year. Okay, and that's going to be down here, guys, is where we're going to talk about that. Sometimes they're going to compound quarterly. Quarterly means 4 times a year, and so our n value will turn into a 4 if they're talking about compounding quarterly. Monthly, there's 12 months in the year, and so if they're talking about monthly, that n will be a 12. If they talk about compounding weekly, that means 52 times a year because there's 52 weeks in the year. And if they talk about compounding daily, that means that our n value is going to be 365 because there's 365 days in the year. Okay, going back, that's what our n value will be right there. Okay, whatever they're going to refer to in the problem, it'll change each problem. Okay, and then our t, which is our exponent. Oh, I forgot to tell you guys that n actually occurs twice in the problem. You divide by it and then you raise it. Okay, and whatever that n is the same value underneath the fraction and raised to the first exponent there. Okay, and then t, guys, is our time in years, which is right here next to the n. They're being multiplied. If you guys have one of the older calculators, one of the old black calculators, guys, you're going to have to make sure that that is either one number that you multiply them together before or that you use parentheses around them, okay, when you're typing it in. All right, so let's go ahead and see in our first problem. Okay, I'll make sure that we can still see the formula. It says, how much would $1,000 invested at a 2% yearly rate compounded quarterly be worth in 20 years? All right, so because they use the word compounded, that's why this is not y equals ab to the x. It's still an exponential formula that we're going to use, but with compounded, it tells us to use this formula that we have up here in the box versus y equals ab to the x. Both formulas will give you an amount that is close to each other, but we want to make sure that we have the exact correct amount, and we won't get it unless we use the correct formula. So because it says compounded, guys, we have to make sure that we're using this formula. Otherwise, we won't get the exact amount we're supposed to, okay? All right, so in this problem, guys, I'm going to go ahead and write down my variables just like I do normally. Okay, I'm going to do it off to the side here. I feel like I might have a little bit more room. But we have an a of t value, which is our final amount, which we do not know in this problem. Okay. We have a p-value, which is the amount or the initial amount that we're putting in, which is $1,000. Our next variable is r, which is our rate. And we have 2%, which as a decimal is 0.02. Notice, guys, that we don't have to do 1 plus or 1 minus because the formula already has the 1 plus built in. Okay. And then we have our n. Because we're compounding quarterly is 4 times a year, so our n will be a 4. And then we have our time frame. And because they're saying 20 years, That means t is going to be our 20. Okay. All right. So we're going to go ahead and plug in, and we're going to go ahead and say that we have a of t. And you guys could replace t if you wanted to. It's not going to affect your answer. But our t, guys, is 20. So if you want to show that you're getting this y value or your a of t value, guys, by plugging in 20, you could put a 20 here. It doesn't matter if you do or don't. Okay? It's not going to affect your answer. Our p value, guys, is 1,000. And then in parentheses in the formula is 1 plus our rate, which is 0.02, divided by n, which is 4. And then it's raised to the 4 times t, which is 20. All right, and so we're going to end up with our amount or our final amount after 20 years. All we have to do, guys, is literally type it into your calculator exactly how you wrote it. The only thing you got to be careful of is you have the older calculator, that 4 times 20 either needs to be turned into an 80 or you need to use parentheses around your 4 times 20. Okay, go ahead, guys, and type it right into your calculator. 1,000 parenthesis 1 plus 0.02 divide by 4, close the parenthesis, caret 4 times 20. When you hit enter, you should end up with 1,490.338,568. And again, guys, it's important that you write down your decimals, or at least most of them, so that in the next step I can tell your rounding is correct, okay? Because there is no nearest or anything like this, but that is money. Money without rounding directions, guys, always gets rounded to the nearest hundredth. So we're going to round that 3 spot, but we have to look next door at the 8. And because the 8 is 5 or higher, it makes that 3 spot go up to a 4. And so we're going to finally say our answer is $1,490.34. And that's how much money, guys, if we put our $1,000 into a bank that compounds quarterly at 2% yearly rate for 20 years, this is how much I'm going to end up getting out. And you notice, guys, that it did grow, and it's supposed to grow because it's interest. All right. And you made about $490.34 in 20 years. Okay. So free money. Woohoo. All right. So the next part says, what if it was compounded monthly? So the only thing that we have to change, guys, is that we're compounding monthly. Oops. And monthly, there's 12 months in a year. And so that's going to make us change our n value. Oops. A lot of whoopses. We're going to change our n value to a 12. All right. So basically, guys, take what you just typed into your calculator and change your 4 to a 12. Okay. And when you change your 4 to a 12, don't forget to change the second 4 to also a 12. Okay. And you retype that in, you're going to end up with, and I'm going to go ahead, guys, and just round in my screen when I type it in. It's going to be $1,491.33. And so you're going to notice, guys, that if this bank compounded monthly versus compounded quarterly, you would make just a little bit more money. Not a ton, but a little bit more. Okay. Next one up, it says, what if you compounded weekly? Well, with weekly, guys, being our compound word, that's going to change our n number again. Weekly, there's 52 weeks in a year, and so we're going to change our n value this time to a 52. And so I'm going to come up here, and I'm going to change that, okay, from a 4, and I'm going to now make that a 52. All right, and I'm going to type it in just like I wrote it, okay? Or you can grab what you just typed in, change the 12 to a 52, and we're going to end up with, and I'm going to round in my calculator screen, guys, just for sake of room and time in our notes today, but we have $1,491.71 it would round to. And you're going to see, guys, that if you put your money in a bank that compounds weekly, that you would get slightly a little tiny bit more money. But more money is always good, especially when it's free. All right. So that's even more than compounding monthly. So hopefully you guys are seeing that the more times of a year that you compound, the little bit more money it's going to change and be more. All right. Next one up, guys, says, what if it was compounded daily? So again, guys, daily is our keyword. That's going to tell us to change our N value to 365. So I'm going to come up here, guys, change both N values to 365 and retype that in. And we're going to end up with $1,491, but 81 cents that rounds to. And you're going to see that that's just 10 cents more, but 10 cents is 10 cents, okay? When you're talking about money and talking about free money. So the last question, guys, says, what do you notice about your output and the number of times interest is compounded throughout the year? And we're going to say, guys, as N increases, which means the more times you compound a year, the output or how much money you're getting out also increases. All right, so you always want to put your money into a bank that compounds the most amount of times per year to get the most amount of money out of your money that you put in, okay? So it says to maximize your output or your money, interest must be compounded what they call continuously, which we haven't talked about yet. But that is going to be the amount that you can compound the most by. All right, so compounding continuously beats compounding quarterly, it beats compounding monthly, it beats compounded weekly, and it beats compounding daily, okay? Compounding continuously would be where you want to put your money if a bank offers compounding continuously. All right, so this is a formula for compounding continuously. So they use a completely different formula, although you guys are going to see some similarities in that A of T is still going to be your final amount. P is still going to be your initial amount, but then there's this E. And E, guys, is actually in our calculator, okay? It's what they call a constant. It represents one number, and it's always the same number. Okay? It's 2.71828, blah, 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 blah. It goes on forever. It's kind of like how pi represents 3.14159, dot, dot, dot. E represents this number, okay? And you can get it by pressing second and your LN button in your calculator. Okay, so if you go to your calculator and you type in second, and LN, guys, is 2 keys above your on key. Okay, it's an L and an N, and right above that LN, guys, because we pressed our second key, is E to the X. And if you want to know what E is, you would make the exponent a 1 because E to the first power is just E. And when you hit enter, guys, you're going to see that 2.71828 number, okay? So we don't have to worry about plugging anything in for E. E is already basically in our calculator, okay? We just have to make sure that we're using that E button. Our rate, guys, is going to be, or our R is going to be our rate again. Okay. When they give it to you as a percentage, you have to make sure that you are turning into a decimal so that you can use. Okay. Notice, guys, there's no 1 plus in this problem. There's also no 1 minus. Because this is an interest formula, guys, they've already built it into the formula. So even though you don't see the 1 plus, because of our base being 2.71828, that E value, it's already into the formula, so you don't have to add in your own 1 plus, okay? And you're definitely not going to do 1 minus because this is interest formula. It always goes up. And then T, guys, is our time in years. Again, if you have an older calculator, guys, you're going to either need to multiply R and T together or use parentheses around them when you type it into your calculator, okay? All right, here we go, guys. So in our question here, it says how much would $1,000, oops, I don't want to cross it out. I just meant to highlight it. My highlighter and my pen look so similar on here that I tend to pick the wrong one. So it says how much would $1,000 invested at 2% yearly rate compounded continuously. So because they say continuously, guys, that's why we're using this formula right here. Okay, we cannot use the formula that we just learned because there isn't a number where we would insert for continuously like we do weekly and monthly and daily and quarterly, okay? How much would it be worth in 20 years? All right, so because they said compound continuously, guys, I now know that the formula that I have to use in order to get the correct answer out is A of T equals PE to the RT, okay? A lot of people will call this formula. And so here we go, guys. So A of T is our final amount, and I don't think we know what that is. We want to know how much we're going to get out, okay? Our P is our initial amount, or what we're putting in, which is $1,000. E is already in our calculator, so we don't count it as a variable down here in our list. Okay. Our rate, guys, is 2%, which is 0.02. And again, guys, this formula does not use 1 plus or 1 minus, okay? And then our t value is our time, which is 20 years. All right, so now all we're going to do, guys, is take our formula and plug in. Again, guys, you can call this A of t, or you can call it A of 20. Doesn't matter if you leave it a t or you put in a 20. It's not going to affect your answer. Okay? Our p value, guys, is 1,000. Then we have that e. Okay? And then as the exponent, guys, way up in the air is 0.02, which is our rate, times our time, which is 20. Again, if you have an older calculator, guys, you're going to need to make sure that 0.02 times 20 is in one set of parentheses. Okay? All right, guys, if you grab your calculator and type that in, 1,000, you're going to have to hit second and your ln key to get the e. It gives you a spot for an exponent, okay? And you're going to type in 0.02 times 20. Okay, notice that 0.02 times 20 in your calculator screen is in the exponent, okay? Hit enter, guys, and we're going to end up with 1,491.824698, okay? There is no rounding directions, but this is money, and so we're going to round to the nearest cent, which is the hundredth place. Underline it, which is the 2. Look next door, it's a 4. It's not going to move it up. And so we're going to say that we are going to end up making or having $1,491.82. And if you compare this number, guys, to our number that we got up here, it's slightly more. I know that it's only a penny, okay? But this is the most money you can get out under those circumstances if the bank is compounding your money continuously, all right? And I know that a penny isn't a whole lot, but it's free money. And so we have to make sure that our math is accurate. And so we have to make sure that we're using the correct formula. Okay. All right, guys. So those are our 2 formulas for compounding. Okay. Notice PERT, guys, is for only compounding continuously. If you're compounding under quarterly, yearly, weekly, something that gives you a number, we have to use the first formula. All right, guys. I'll see you on the backside of notes.